Hello, everyone, and welcome to a new episode of the Daily Math Olympiad Problem Challenge. And today we're going to tackle a problem from the Junior Math Olympiad from 1997. So let's go. Determine the triangle with sides A, B, and C, circumradius R, to which R times B plus C equals A times square root of B times C. So this might seem like a challenging problem, but it is pretty straightforward. What I would recommend is that we try and establish kind of a relationship between R and the sides A, B, and C, other than this equation, so that we can work on that. And I will simply use a formula from area. You might know that there are lots of formulas for the area of a triangle, and one formula that connects the sides of the triangle and the circumradius is this one, which states that the area of a triangle with the sides A, B, and C is basically the product of all the sides divided by 4 times the circumradius. So secondly, what I would do is write this formula we have right there in terms of R, so that we can plot in the term we get in the equation for the area, and then we'll work on it. So firstly, I'm gonna write this formula, and then we're gonna plot this formula right there. And now the step we're going to make is simply to simplify this expression. So we got A cancels with B, now we got B, Z. And we can simplify it again, since B times C divided by the square root of B and C, simply a square root of B and C. See? And this is the expression we get. And we can see that now we wrote the area of this particular triangle we are looking for in terms of B and C. And what we're going to do now is to formulate another formula for the area of a triangle in terms of B and C, and we can do it with the sine of the angle. So we can define this formula, which states that the area of a triangle is basically a product of two sides divided by 2 multiplied by the sine of the angle, which is between these two sides, and this angle is going to be alpha, for example. And since this is the area of a triangle and this is also the area of a triangle, we can equate these two equations. So now we're going to get this final equation. And the goal is going to be to write this equation in terms of the sine of alpha, so that we might get some other information which might be useful to solve the problem. And this is what we're going to get for the sine of the angle. For the sine of alpha, this is going to be this expression. Now, what is important for the sine of alpha? Alpha is an angle which is inside the triangle. So this means that we have only some possible values for alpha. We know that sine of alpha is definitely going to be bigger than 0, but it's also going to be smaller than or equal to 1. And you can simply plot in this term right there. Now what's interesting now is that we're getting this term on this side, and if we multiply the expression by 2 times square root of BC, we get a new inequality, which states that 2 times square root of B and C is bigger than or equal to B plus C. And this is pretty similar to the arithmetic geometric mean, if you're familiar with that, which states that for two numbers A and B, it states that the arithmetic mean of these two numbers is bigger than or equal to geometric mean of the numbers. But in this case, we're getting basically the same inequality, but inverted. And because of the fact that we know that this inequality is true, and this should also be true for this case, we know that we have a form of equality in this case. So we know that B is equal to C. And this is very important because now we can calculate directly the sine of the angle. Because we know that B is C, we can write a new formula for the sine of the angle, which states that it's basically B plus B divided by 2 multiplied by the square root of B times B. since we know that C equals to B. And because of that, we can simplify the sum. We get that 2b over 2 times square root of b squared. Square root of b squared is simply going to be b. So we get the sine of the angle is basically 1, as those two cancel out. And what does this mean for the angle? It simply means that alpha is 90 degrees. And this is very important because it means that we solved the problem. The goal of this problem was to determine which triangle we're looking with sides A, B, and C, and particular circumradius for which this is true. And what we came to was a triangle with a right angle and two isosceles sizes. So in this case, we have B, C, A. We have a right triangle and two sides with our same. So this simply means that because the two sides are the same, these two angles are also going to be the same. And because the sum of angles in the triangle is 180 degrees, this angle right here, gamma, is going to be 45, and beta is also going to be 45. So the triangle we found is a 90, 45, 45 triangle. And that is basically the answer. So for side A, B, and C, what we're going to get is that B and C are simply n, two sides n, which are same, and A is simply going to be the hypotenuse like we had in this triangle. So in this case, it's simply going to be square root of 2 times n, and that is the solution. And this is how you solve a problem from a Junior Balcom Math Olympiad. If you like the video, please subscribe and write in the comments whether you solved it or not.